Welcome, superstars! If you're gearing up for your board exams and you really want to nail geometric progression, you have come to the perfect place. In this one-shot guide, we're going to cover everything: the core ideas, the must-know formulas, and the strategies to solve problems so you can walk into that exam feeling totally ready. Let's get started.
Okay, so to really get what geometric progression, or GP, is all about, it's super helpful to look at its cousin, arithmetic progression, or AP. Now, AP on the left is like taking steady, even steps. You're just adding a fixed number over and over. In this case, plus 4, plus 4, plus 4. But GP, well, GP is a whole different ballgame. It's all about multiplication, which means you get these huge leaps. We're multiplying by 3 each time, and look how fast it grows. This tiny difference, adding versus multiplying, is everything. It's the secret to GP's power.
And this quote from Thomas Malthus, it just hits the nail on the head. It shows you the massive real-world impact of that huge leap we were just talking about. You know, food supply might grow steadily, step by step, like an AP. But things like population, or hey, even a viral video on the internet, they can absolutely explode. That's a GP in action. This is what we call exponential growth, and it's why GP is such a mind-blowing concept in math.
All right, so we've got the what and the why down. We get what a GP is and why it's a big deal. So now it's time to build our toolkit. We're about to break down all the essential formulas and terms you're going to need to solve basically any GP problem they can throw at you.
So at the very heart of every single GP, you've got 2 main players. First, you've got A, which is your first term. That's your starting block. And then you have R, the common ratio. Think of R as the engine that drives the whole thing forward. And how do you find R? It's super simple. You just divide any term by the one right before it. So if you have 2, 4, 8, you just do 4 divided by 2 or 8 divided by 4, and boom, you know your common ratio is 2.
This formula right here, this is your absolute #1 tool. If you need to find any specific term in a GP, I don't care if it's the 5th term or the 50th term, this is your key. A is that first term, R is the common ratio we just talked about, and N is just the position of the term you're hunting for.
Okay, so finding a specific term is great, but a lot of the time, the exam's going to ask for the sum of a whole bunch of terms. I mean, you're not going to sit there and add up 20 numbers one by one, right? No way. Luckily for us, there's a formula for that too. Now, here's the thing. When it's time to find the sum, you have to make one really important decision first. And it all boils down to R. You see, there are 2 different formulas, and which one you use depends on whether the absolute value of R is bigger than 1 or smaller than 1. Picking the right formula right from the start, like you see on the slide, is the absolute key to getting the right answer and not making a silly mistake.
All right, now for a pro move. This is a seriously cool trick that's going to save you a ton of time and effort in your exams. We're going to call it the smart selection method. So you're probably thinking, wait, why wouldn't I just use the normal A, R, and R squared? And yeah, you could, but this specific method, it's a strategic shortcut. It's especially useful when a question gives you the product of the 3 terms. So let's see why this is such a brilliant move.
And here is where the magic happens. When you multiply these 3 terms together, just look at what happens. The R on the bottom of the first term and the R on the top of the last term, poof, they just cancel each other out. You're immediately left with A cubed. This makes finding A so incredibly simple. Trust me, for certain problems, this is a total game changer.
Okay, theory's covered. We've got a clever trick in our back pocket. Now, let's put it all together and get our hands dirty with some real-deal board exam problems.
Okay, problem number 1. Let's break it down. We've got this sequence, and our target is the number 81. The question is really simple. Where does 81 live in the sequence? What's its position, its n value? Is it the 4th term, the 5th? Let's figure it out.
First things first, in any problem, you've got to pull out the information you already know. Let's look at our table here. Looking at the series, A, the first term, is obviously 1. The common ratio, R, is just 3 divided by 1, which is 3. The term we're aiming for, our AN, is 81. So the only piece of the puzzle we're missing is N.
Now we just take our values and plug them straight into that nth term formula. That gives us 81 equals 1 times 3 to the power of n minus 1. Now here's the key move. You have to recognize that 81 is just 3 to the power of 4. Once you do that, the bases on both sides of the equation are the same, they're both 3. So we can just equate the exponents. n minus 1 equals 4. A little bit of simple math, and we get n equals 5. So 81 is the 5th term. Done.
And here we go, a classic word problem. This is the kind of thing they love to put on exams. Notice it doesn't scream, hey, this is a GP.
You have to be a detective. You read it and see the pattern. 10, then 20, then 40. He's doubling his spending every single day. That constant multiplication is your big flashing sign that you're dealing with a GP. So once we spot that pattern, we do what we always do. Pull out the data. The first term, A, is 10. The common ratio, R, is 20 divided by 10, which is 2. The question asks for the total over 12 days, so N is 12. And since our R value is 2, which is greater than 1, we know exactly which sum formula to grab from our toolkit. And when we plug in all our values, A is 10, R is 2, N is 12, and we crunch the numbers, we get this, a whopping 40,950 rupees. That is a fantastic example of just how ridiculously fast a GP sum can grow. It starts small and then just skyrockets.
All right, to wrap this all up, let's talk about the common mistakes, the little traps people fall into. Knowing what to watch out for can honestly be the difference between getting a good score and getting a great one. This is how we lock in those full marks.
Okay, listen up, because this is a big one. A really, really common place where students lose easy marks is when they're dealing with a negative common ratio. The sequence starts flipping between positive and negative, and this is where you have to be so careful with your calculations. Let's see why.
You heard the man. As Sir Tarun Rupani says, a minus sign is a danger sign. Seriously, when you see a negative R in a problem, it should be like a little alarm bell going off in your head, telling you to slow down, wake up, and double-check every single step, especially with exponents.
This right here, this is the rule you need to burn into your brain. A negative number, like -2, raised to an even power, it becomes positive. But that same negative number raised to an odd power, it stays negative. Forgetting this simple but absolutely critical detail is probably the #1 reason people make mistakes with negative ratios.
So let's bring it all home. Our strategy for success is simple. Number 1, master your formulas. Know them forwards and backwards. Number 2, become a pattern spotting expert, especially in those word problems. And number 3, always check your signs when you're working with negatives. If you can get these 3 things right, you will be in amazing shape.
You all did some fantastic work today. You now have a solid, complete toolkit for crushing any GP problem that comes your way. But hey, don't let the learning stop here. Think about this question. Look around you for examples of geometric progression in your daily life. I promise, it's everywhere. Thanks so much for joining me for this explainer.